Welcome back students, good morning. So in this class we are going to study about the Hungarian method for solving assignment problem. But in the previous section we have come to know what is assignment problem and how the mathematical formulation of assignment problem is done. That is the number of sources should be equal to the number of destinations, and in the last previous topic is we have written the differences between transportation problem and assignment problem. So all this done, finished now. Now we are supposed to find an algorithm or learn an algorithm to solve the assignment problem. That algorithm is called as Hungarian method. Right? So let me write here. It is Hungarian method. So students, one question carrying 8 to 10 marks is 100% sure on this method. Either they ask you the algorithm to write or they ask you to solve the problem using this Hungarian method. But in both the cases, first of all, you should know what is this Hungarian method. In supposed to say in Kannada. So ನಿಮಗೆ ಎರಡರಲ್ಲಿ ಒಂದು ಕ್ವಶನ್ ಮಾತ್ರ ಪಕ್ಕಾ ಇರ್ತೈತೆ ರೀ. ಏನಪ್ಪ ಅಂದ್ರೆ ಒಂದು ಹಂಗೇರಿಯನ್ ಮೆಥಡ್ ಅಲ್ಗಾರಿದಮ್ ಬರಲಿಕ್ಕೆ ಹೇಳ್ತಾರೆ, ಇಲ್ಲ ನಿಮಗವರು ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಿರಿ ಯೂಸಿಂಗ್ ಹಂಗೇರಿಯನ್ ಮೆಥಡ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಬಟ್ ಎರಡೂ ಮಾಡ್ಬೇಕಂದ್ರೆ ಫಸ್ಟ್ ನಿಮ್ಗೆ ಏನು ಗೊತ್ತಿರಬೇಕು, ಹಂಗೇರಿಯನ್ ಮೆಥಡ್ ಗೊತ್ತಿರಬೇಕು. ಸೊ ಲೆಟ್ ಅಸ್ ನಾವ್ ಸ್ಟಡಿ ದ ಹಂಗೇರಿಯನ್ ಮೆಥಡ್. ಸೊ ದ ಸೊಲ್ಯೂಷನ್ ಆಫ್ assignment problem can be arrived using Hungarian method. The steps are as follows. Right? So step number 1. Step number 1, prepare a cost matrix. Prepare a cost matrix. If the cost matrix is not a square matrix, then add dummy row or column with 0 cost element. So let me explain you the first step here. When an assignment problem is given to solve you, the first condition is what? The number of sources should be equal to number of destination. I mean to say, the cost matrix should be a perfect square matrix. If at all it is not a perfect square matrix, then add a dummy or a dummy column or a dummy row to make it a perfect square matrix. So rows or columns can be added. What cost should be added there inside that row or a column? So we have to insert zero cost element inside a dummy row or a column. Fine. So the first step will say that if it is not a square matrix, add a dummy row or a column to make it a square matrix, and also add zero cost element. Fine. So in step number 2, subtract the minimum element. Subtract the minimum element in each row from all the elements of that respective row. Fine. What is the second step here? Subtract the minimum element in each row from all other elements of that particular row. If I suppose to say it in Kannada, ಪ್ರತಿಯೊಂದು ರೋ ಅಲ್ಲಿ ಇರುವಂತ ಅತಿ ಕಡಿಮೆ ಎಲಿಮೆಂಟ್ ಅನ್ನ ಏನ್ ಮಾಡ್ರಿ ತಗೊಂಡು ಉಳಿಕಿದ್ದ ಎಲಿಮೆಂಟ್ಸ್ ಗಳನ್ನ ಆ ರೋದಲ್ಲಿರುವಂತ ಉಳಿಕಿದ ಎಲಿಮೆಂಟ್ಸ್ ಗಳಲ್ಲಿ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ತಾ ಹೋಗ್ರಿ. ಫೈನ್. Subtract the minimum element in each row from all the elements of that particular row. Fine. Third one, further modify the resulting matrix by subtracting minimum element of each column from all the elements of respective columns. Thus obtain the modified matrix. So what is step number 3 says here? Step number 3 tells what you are supposed to do. The thing what we have done in step number 2, we have to do it in step number 3, but here we are doing with the columns. Means we need to subtract minimum element in the each column with the other elements of that column. Fine. Once we do that, we will obtain the modified matrix. Again, I am going to repeat the step number 2 and step number 3 here. What step number 2 will does, we need to find the minimum element in each row and subtract with the other elements of that row, and we have to do that for all the rows. And the same thing in the step 3, we have to find the minimum element in each column and subtract that element with the other elements of that respective column, and we have to do it for all the columns. So once we done with each row and each column, we will get or we will obtain the modified matrix. Fine. So then go for the next step, that is step number 4. Fine. So step number 4, draw the minimum number of horizontal and vertical lines to cover all zeros in the resulting matrix. Let the minimum number of lines be capital N. Now there are 2